answering questions 21, 23, 24, and 25. So 21 talks about wanting to randomly select a sample of 3 where you have 2 tangerines and 1 is an orange. How we want to do this is we want to do one fraction, and the bottom is going to be all fruit that are in the basket, so 12, C3. We can't repeat, we need 3 different pieces of fruit, but order doesn't matter. Now the top we need to specifically control how many are tangerines and how many are oranges. So from chapter 10 we're going to think fundamental counting principle, and we're going to make the numerator a 2-part task. So now we need to look back at how many tangerines there are. There are 5 total in the basket, so for the 2 tangerines we want to do 5C2 times how many oranges? 7. So you could just write 7, or you could write 7C1. And now we're going to do the math computation to get to our answer. So we're going to do 5 combination 2, and that's 10, times 7, so that's 70. And then the bottom is 12 combination 3, which is 220. The zeros will drop out, and we'll get 7 over 22. Question 23 wants you to figure out the probability that 6 adults selected will all have health insurance under the following conditions. When they already give you a percentage in the problem, it is usually going to be an NPQX problem using the binomial probability formula. N is how many total people are in, so let me see here. Oh, actually, it's not this. My apologies. You couldn't use that because they don't ever tell you how many people are in the town. But we want 6 adults to all have health insurance. A key word here for all, this is a key word for and. So for any one of these people to have health insurance, the likelihood is 0.76. So we're going to do 0.76 times 0.76. We're going to do this 6 times. Because we want all 6 people to have health insurance, and the likelihood that someone from this town has health insurance is 76%. So another way to do this quickly with your calculator is 0.76 to the 6th power. So we get 0.19269, and it says, let me look, it says to round your answer to the nearest, round your answer to 3 decimal places. So we would get 0.193. Question 24 is an expected value problem about insurance. So we're going to draw a probability distribution table here, and what we are supposed to determine is the expected annual gain on such an insurance problem. So X is annual gain, and this is our P of X side. So remember, it says for this policy there's either total loss or there's no loss. So now we have to figure out what's the annual gain if there is total loss. Okay, so a policy holder pays $570 to have an insurance plan. That money goes to the insurance company. However, with total loss, you are going to subtract $280,000 and the $30 that the insurance company has to pay to service this such policy annually. And so you're going to do that with your calculator and get a number. So you're going to take 570 minus 280,000 minus 30, and you're going to get negative 279,460. Now, no loss would be 570 minus the $30 that they pay to service the policy. So they could make 540, they being the insurance company. Now, the probability, they tell you in the problem that the probability of total loss is 0.001. So this is 0.001, and remember, a probability distribution table, if correct, all probabilities add to 1. So you are going to have the other probability be 0.999. Now, to find the expected annual gain, you take each x and multiply it by its corresponding probability. So you take negative 279,460 times 0.001 plus 540 times 0.999. And then we use our calculator to get an answer. And you end up with an answer of $260. Question 25. Question 25 is the digits 1, 2, 3, 4, 5, and 7. So 1, 2, 3, 4, 5, and 7 are randomly arranged to form a 6-digit number. Find the probability that the first and last digits are both even. So you're going to draw out a fraction bar and build a normal probability. The bottom will represent how to arrange 6 numbers. So remember, arrangement means order matters and no repetition is allowed. So we are arranging 6 numbers to make a 6-digit number. So this would just simply be 6 factorial. There are 6 numbers to go first, then 5, then 4, 3, 2, 1. Now the top we're going to break out using the fundamental counting principle into 6 actual place values for a 6-digit counting number. They want us to find the probability that the 6-digit counting number has both an even number on the front and the end. So how many even numbers do we have? We have 2. So there could be 2 different numbers for the first, and then there's only 1 even number for the end. And then these can't be used anywhere else because we're arranging our numbers. So now how many do we have left? We have 4 numbers that arrange themselves here. So 4, 3, 2, 1. So with our calculator, we have 720 in the bottom, and the top is 48, and then they wanted our answer as a fraction, so we need to reduce 48 over 720 to 1/15.